If a point P moves so that its distance from a fixed point, called a focus, and a fixed straight line, called the directrix, are in a ratio which is less than 1, then the locus of the point is an ellipse. So consider the following sketch. S is the focus, and the straight line over here is the directrix. And P is the point on the ellipse, and for the ellipse, PS over Pn divided by Pn, remember Pn is the distance perpendicular to the directrix, is equal to E, where E is less than 1. And E is called the eccentricity. If E happened to be equal to 1, we would get a parabola. The locus would be a parabola. Our study will be restricted to ellipses with a focal point called S with coordinates AE 0 and a fixed straight line with equation x equal to a divided by e, where a is some real number. The Cartesian equation of such ellipses is x squared over a squared plus y squared over b squared equal to 1, where b squared is equal to a squared times 1 minus e squared. Such ellipses cut the x-axis at a0 and minus a0, and cuts the y-axis at 0b and 0 minus b. So in the sketch shows the ellipse. It's cutting the x-axis at a and at minus a, and the y-axis at b and minus b. S and S dash are the foci, and O is the origin or the center of the ellipse, and the distance from the center to a focus is equal to AE. Let's look at this example. An ellipse has its foci at the points minus 3, 0 and 3, 0, and its eccentricity is a quarter. Find the Cartesian equation of the ellipse. First, let's draw a sketch to represent this ellipse. So the points S and S prime are the foci of the ellipse, and from what we were told previously, the distance from O to S, OS, is equal to AE. But OS is equal to 3. E, we are told, is equal to a quarter. Therefore, A times a quarter equals 3, which tells us that A is equal to 12. Now B squared, we are told, is equal to A squared times 1 minus E squared. So substituting, B squared is equal to 12 squared times 1 minus a quarter squared. And you put that in your calculator, you get 135. So the Cartesian equation is x squared over a squared, which is 144, plus y squared over 135 equal to 1. Example 2. An ellipse has its foci at the points -1, 0 and 7, 0 and has an eccentricity of a half. Find the Cartesian equation of the ellipse. Now this is very similar to the first one, except we should note that the foci are not placed evenly to either side of the origin. But let's draw a sketch to first of all see what the situation is. So this sketch shows the ellipse with the relative positions of the foci. And O is the origin of the axes. Now first let's find the center of the ellipse. And the center of the ellipse will be the midpoint between the two foci. So the center C is midway between the foci, and you should be able to see that that is the point 3, 0. Now the distance from the center to a foci is going to be equal to AE. So CS is equal to AE. We know that CS is therefore equal to 4 units. So the distance from 3, 0 to 7, 0 is 4 units. E is equal to a half. So A times 1/2 is equal to 4, which tells me that A is equal to 8. So A squared equals to 64, and B squared is equal to 64 times 1 minus a half squared, which is equal to 48. Now before we write down the Cartesian equation, we have one more variation to apply. Notice that the form that we had before assumed that the center of the ellipse coincided with the origin. So we have to apply a shift to this ellipse so that it matches that requirement. So imagine that I'm going to shift the ellipse over so that the center coincides with the origin. And that situation would be to modify the x values by a transformation of x minus 3. So the Cartesian equation is x minus 3 squared divided by 64 plus y squared divided by 48 is equal to 1.